It took us some time to work through the various symbolic renderings of the religious world, and we did this so we could be quite confident in the core principles of the religious esoteric triad, that we were not inventing or imagining things. In the previous video, we discussed the idea that two forces could not produce phenomena, that to produce phenomena 3 forces were needed, and we discovered that these 3 forces were directly referred to in the literature of Gnosticism, Jewish mysticism, and Gurdjieffian ideology. It can be hard to understand why 3 forces are necessary, and how the 3 forces we specifically looked at are able to produce phenomena. To make this idea more accessible, we can represent these 3 forces from a different point of view, which illustrates the dynamic mechanism which is an intrinsic property of triadic arrangements. We can imagine our 3 differently charged spheres sitting on a seesaw in perfect balance like this. If we remove the middle sphere, so that only the 2 equal but opposing forces remain, then they will also sit in a static balance, effectively cancelling each other out, and nothing further can happen. But because the third force has 2 potentials, it can express itself alternatively as one or another of the 2 opposing forces at each side of the seesaw, from one moment to the next, in one interaction or another. If it manifests as a so-called opposing force, the 2 spheres on this side of the seesaw move the seesaw down. If it manifests as a so-called active force, then the other side of the seesaw moves down. As this third force manifests itself in one way and then the other, the imbalance moves the seesaw up and down, and so it seems that this is the dynamic disequilibrium which produces phenomena. This is perhaps the easiest way to represent the relationship between the 3 forces and the phenomena of the material world. Now we can return to the diagram we are accustomed to and look at the birth of the universe from the point of view of science. As previously discussed, the 2 properties produced by the Big Bang were equal amounts of matter and antimatter. While this seems to be the consensus view of science, there is a rather obvious problem, because inevitably antimatter and matter would obliterate each other, or, as in our seesaw analogy, effectively cancel each other out, and so nothing further could happen. One solution proposed by science is found in the neutrino, which may well be its own opposite or anti-neutrino, and which through complex principles surrounding the subject of lepton number conservation and neutrinoless double beta decay enables the existence of the phenomenological material world. Since the 1930s, scientists have been searching for particles that are simultaneously matter and antimatter. Physicists have also found strong evidence for these so-called Majorana particles in superconducting material, from a recent edition of Scientific American. Physicists think that every particle of matter has an antimatter counterpart with an equal mass but opposite charge. When matter meets its antimatter equivalent, the 2 annihilate each other. But some particles might be their own antimatter partners, according to a 1937 prediction by Italian physicist Ettore Majorana. For the first time, researchers say they have imaged one of these Majorana particles and reported their findings in the October 3rd Science. But yeah, make no mistake, physics is not my area of expertise, so all I can offer is a very basic overview of the idea at the simplest level from a lay point of view. Nevertheless, it is interesting that this scientific theory maps precisely on the schematic we recognized in religious triads. Science also speaks of 3 fundamental forces specifically. The recently deceased legendary physicist Stephen Hawking spent a good deal of time investigating something called the Grand Unifying Theory, or GUT for short. A grand unified theory is a model of particle physics in which at high energies the 3 gauge interactions of the standard model that define the electromagnetic weak, and strong interactions, or forces, are merged into a single force. Although this unified force has not been directly observed, the many GUT models theorize its existence. If unification of these three interactions is possible, it raises the possibility that there was a grand unification epoch in the very early universe in which these three fundamental interactions or forces were not yet distinct. So the Gnostic idea of the pleroma, as described by Jung, is quite similar to that of the proposed grand unification epoch, and the idea of three emergent forces, when the state changed, is common to the heterodox teachings of Gnosticism, Jewish mysticism, Gurdjieff, and modern science. These three fundamental forces also map quite well onto our schematic. The strong nuclear force is an attractive force between protons and neutrons that keeps the nucleus of an atom together. And the weak nuclear force is responsible for the radioactive decay of certain nuclei. The electromagnetic force is a force that occurs between electrically charged particles, such as electrons, and is described in electrostatics as being either positive or negative. Objects with opposite charges produce an attractive force between them, while objects with the same charge produce a repulsive force. Then, if we consider the emergence of matter as understood from the point of view of classical physics, we find the first element, and the most abundant element in the universe, is formed by the simplest of all interactions. Protium, or as it is more commonly known, hydrogen, has one positively charged proton and one negatively charged electron. Every other element beyond this point is composed with the same three particles: an electron, a proton, and a neutron, which has a neutral charge. The simple electrical circuit so precisely maps these concepts of the esoteric religious triads that we have used it throughout our videos to clarify the central ideas. When we look deeper still at the subatomic particles that compose matter, we find them divided into three overlapping families: hadrons, fermions, and bosons. Hadrons comprise most of what constitutes ordinary matter. They include composite fermions such as neutrons and protons, while elementary particles such as the electron belong to the fermion family, and the bosons are mostly force carriers. Elementary or fundamental particles like the electrons have three categories: quarks, leptons, and bosons. So while the electron has no internal structures for us to consider in further detail, the neutron and proton do. The neutron is composed of three quarks, two down quarks and one up quark. The up quarks effectively have a positive charge. The down quarks effectively have a negative charge. The so-called colour assignments of individual quarks is arbitrary, but according to science, all three colours must be present for reasons that only physicists could adequately explain. The proton, on the other hand, is also composed of three quarks, but this time two up quarks and one down quark. The charge differences in the up and down quarks in the protons and neutrons cause them to bind together courtesy of the strong force in the nucleus of the atom, creating a positive imbalance which in turn is stabilised by the electrons which orbit the nucleus. Forces between these three quarks are mediated by three force carriers known as gluons. Although my knowledge of physics is scant, as previously stated, it is enough perhaps to demonstrate that the elemental atomic level and the subatomic level of the material world conform to the schematic of the law of three forces evident in the esoteric religious triads of antiquity. The differences in the so-called up and down quarks within the proton and neutron, somewhat coincidentally, also map quite well onto our seesaw allegory. Quantum computing provides us yet another example of how these three forces appear in the ordinary world. Currently, we use a binary code system where all the data which makes up our text, images, and media is composed of only ones and zeros. In this example, the 1 represents a unit, a quantity, or something, while a 0 represents the opposite, the absence of a unit, the absence of something. The modern binary number system, which is a basis for the binary code, was invented by Gottfried Leibniz all the way back in 1689 and appears in his work Explication de l'arithmétique binaire. Binary numbers were a mathematical analogue of Leibniz's religious philosophy. They were symbolic representations of the Christian idea, which is increasingly similar to the scientific position, creatio ex nihilo, or creation out of nothing, ideas that we have already covered in this section. After Leibniz had developed his ideas, he discovered the classic Chinese text called I Ching, or Book of Changes, which, he realised, used 64 hexagrams of 6-bit visual binary code. The I Ching was based on the yin and yang, or the union of opposites. Just as a popular historical dualist worldview was replaced by the tripartite worldview, which was taught by the mystery school since antiquity, the binary system of computing is in the process of being transformed into an infinitely better base code, and one that is schematically identical to esoteric religious triads. There are 2 possible outcomes for the observed quantum bit, which are generally represented by 1 and 0. 1 can also be seen as positive, since it represents something. The 0 can be regarded as negative, since it represents the absence of something. But the quantum bit, according to quantum mechanics, can also be a coherent manifestation of both at the same time. According to Wikipedia, George Boole published a paper in 1847 called The Mathematical Analysis of Logic that describes an algebraic system of logic now known as Boolean algebra. Boole's system was based on a binary, a yes-no, on-off approach that consisted of the 3 basic operations and, or, and not. This system was not put into use until a graduate student from Massachusetts Institute of Technology, Claude Shannon, noticed that the Boolean algebra he learned was similar to an electric circuit. Shannon wrote his thesis in 1937, which implemented his findings. Shannon's thesis became a starting point for the use of binary code in practical applications such as computers, electrical circuits, and more. Early in the 17th century, Francis Bacon realised that these ideas need not be restricted to mathematics, but could be applied to all kinds of other manifestations capable of being represented by binary opposition, such as musical sounds. Wilhelm Friedrich Hegel, an influential philosopher of the 19th century, describes a perfect representation of the law of 3 in his well-known political theory of thesis, antithesis, and synthesis, which Kant applied outside the political realm later. So the like-for-like representations that we have touched on here in the world of physics, cosmology, mathematics, philosophy, and technology are merely the tip of the iceberg, and there is enough material in all this to write several books. My intention, though, is only to provide enough examples so that the scientifically minded are able to take the ancient religious idea of the law of 3 forces and what it represents a little more seriously. Thanks for listening.